Alright guys, welcome to this page of the notes, and I apologize. That first one I do like our first example problem generally to be a little bit trickier, because normally you watch that first example problem with me to kind of figure out how these go. These ones are a little bit simpler. So with any luck, maybe you've gone on, tried them on your own, and you're coming back to check your answer. If that's the case, let's see how this works out. Remember, step number one is I got to find the excluded values, which is actually very easy to do in this case. The only way I get 0 in the denominator is if x is 0. So we're going to need to exclude a 0 in step one. Just let me make that little note right over here on the side. Step number one, x cannot be 0, right? Because if I plug a 0 in there, that gives me division by 0. If I plug a 0 in there, 5 times 0 is 0, that gives me division by 0. But anything else will be fine. It won't give me division by 0. So just x can't be 0. Then step number two, well, what I need to do is solve the related equation. So we're just going to skip a couple of steps here. I think you can probably pretty easily see 5 is prime and 3 is prime. So I'm going to wind up with an LCM of 3 times 5, which is 15. And then, of course, the factors of x is just x. So 15x. I'll multiply everybody by 15x, and let's see what this looks like. I wind up with 15x times 5 over x plus 15x times 6 over 5x is equal to 2/3 times 15x. Here's what happens. The x cancels with the x cancels with the x, the 5 reduces the 15 to a 3, and here's what we've got. 15 times 5, jump my calculator real quick here, 15 times 5, we wind up with 75. So that gives me 75 plus, let's see, the x is dropped out. I just have 3 times 6, which would be 18. On the other side, ooh, look at this. The 3 cancels with the 15, reduces it to a 5. And so what I wind up with on the other side is 2 times 5, which is 10x. All right, we'll leave the 18 on this side. I have 10x minus 7x, which means 18 is equal to 10x minus 7x should be 3x. Ooh, look at this. X is equal to 18 divided by 3, which means x is 6. Okay, so I've got check this out, 2 excluded values. This will actually, here, let me do them in a different color. This one and this one. So if you guys remember then, step number 3 is to take those excluded values, drop them on a number line to split that number line up into intervals, and then go ahead and test those intervals. Oh, wait, I'm sorry. I am so sorry. Hang on. Oh, I don't even know what I'm doing. I'm sure you probably caught that and are wondering, why do they let this guy teach math? I wonder that sometimes myself as well. 15 times 5, we said is 75, but then I wrote 7x. Crazy. Forgot to take my medication this morning. So there we go. 75 plus 3 times 6 is 18 is equal to 10x. Here we go. Let's do that then. So we wind up with 75 plus 18 gives me 93. X is equal to 93 divided by 10, which comes out to be, as a decimal, how about 9.3? All right, I almost goofed big time, but we saved it. Okay, great, here we go. So I need to drop the values from step 1 and step 2 onto a number line. I still can't believe I did that, 75, holy moly. All right, so 9.3 and 0, here's my number line. Let's see how this goes. -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and I need 0 is excluded, not that one, and 9.3, which will be somewhere right about in there. Again, you don't have to be exactly wrong. Throw those dotted lines in there, and there we go. I can clearly see I have 3 intervals. I have anything less than 0, between 0 and 9.3, and then greater than 9.3. Let's go ahead and pick a couple of values. How about we do x equals a -1? Well, if I go ahead and plug a -1 into the original inequality, so a -1 there and a -1 right there, what you're going to find is that this actually turns out to be a number that is less than 2/3. Less than 2/3, which of course is false. Because the inequality says that this side should be greater than 2/3. So it turns out to be false. Let's go ahead and pick a number on this side. How about x equals 1? Because 1 is easy to do. I go ahead and throw a 1 in there and a 1 in there. Go ahead and do it. And yes, I get a number on this side. Please feel free to use a calculator. You would take 5 plus 6/5, and it will come out to be bigger than 2/3. So this is true. And then you go ahead and pick something bigger than 9.3. I would just do x equals 10. Anyway, you wind up getting a false statement when you go ahead and plug a 10 in for x and a 10 in for x. And what that means is the only area that was true was everybody right in there. And so what I get is I need all values. My domain is anything that is strictly less than 93/10 or 9.3 and greater than 0, strictly greater than 0. Again, if you wanted to write that in interval notation, 0 to 9.3. Those would be the values of x, interval notation. But I actually, in this case, would just go ahead and do this one. You also could do set builder notation, all values of x such that greater than 0, less than 9.3. Actually, either one of those would be your winners. The interval notation is not that great for this one, but either one of those would work awesome. Okay, hey, let's go ahead and see if we can quickly get through one more here. I think this one will go pretty fast too. It's pretty easy. Again, I quickly take a look at it, exclude values that I know I can't use, which again is going to be step 1 if x is 0. So x cannot be 0, right? Because if I plug a 0 in there, they give me division by 0. Plug a 0 in there, 3 times 0 is 0. So it's 0 is the only one that doesn't work for step 1. Step number 2. Okay, so I know I need to solve the related rational equation, but I take a look at this, and here's what I see. 9 is a 3 squared. This would factor into a 3x, and that would just be an x. Well, 3 squared is 9 and x, so your LCM, you should be able to pretty quickly tell LCM is 9x. So here we go. We have 9x times 4 over 3x plus 9x times 7 over x is equal to 5/9 times 9x. All right, so the 9's are going to cancel. The x's are going to cancel. The x's are going to cancel. 3 is going to reduce that to 3. And so I have 3 times 4, which is 12. 12, and then I wind up with, right, is that what I get? Hang on, so my 9's, x's cancel. Yeah, awesome, and x's go away, and I should wind up with 12. Great, so then it looks like on the other side, yes, x's cancel, so 9 times 7, we wind up with 63. And then the 9's canceled, and I get 5x. Okay, fantastic. Let's see, 12 plus 63 plus 12, 575. I believe that is 15. All right, so I've got my excluded values of 0 and 15. Step number 3, let me slide up here a little bit. Throw these guys on a number line. I'm going to wind up skipping around a little bit here. It was -2, -1, 0, 1, 2, skip a whole bunch, 13, 14, 15, 16, 17. All right, so 0 is out, 15 is out. That splits my number line into intervals. Go ahead and pick some easy values. Let's do x equals -1. We'll do x equals 1 and x equals 16. Again, remember, you just plug those values into the original inequality. If you did so, you would get that this one comes out to be a true statement. This one comes out to be a false statement. This one comes out to be a true statement. So we shade our number line. That's all good. That's all good. And so here's what we would wind up with. I guess I would write this one in interval notation since they're going in opposite directions. So my domain is negative infinity to 0, not included, so I use a parenthesis. Remember that U stands for union, so it's this set of numbers in addition, unioned with this set of numbers. 15 is not included, so parenthesis, and then all the way to positive infinity. And that would be the domain. As long as you pick an x value somewhere between 0 and negative infinity, it'll work. Pick an x value somewhere between 15 and positive infinity, it will work for the inequality that I gave you in this problem. All right, guys, I believe I have one more for you on the next page of the notes. Head on over there. We'll take a look at it together. I'll meet you there.